Okay, so we'll talk about three important processes now. So essentially, you always remember here pressure, volume, and temperature. These are the key parameters in thermodynamics, and based on that, we have a constant pressure process, a constant volume, and isothermal process, where the temperature of the system maintained. And there is also a process that is called adiabatic reversible process. In a constant pressure process, the del P equal to 0. In a constant volume process, delta V equal to 0. That means del W will be 0. Isothermal process, del T equal to 0. And in adiabatic process, the delta Q is 0. So these are important parameters. So for let's start with the constant pressure process. So how we deal with the constant pressure process and how we have a treatment for the constant pressure process from first law of thermodynamics. So constant pressure process means, let's say I want to determine the amount of work done in a constant pressure process. Remember that this delta Q cannot be calculated directly. Either in any questions you will encounter, this amount of heat added or amount of heat extracted to the system is an experimental parameter. So you cannot really directly calculate the delta Q. We'll always calculate delta Q in terms of a function or from the equation or in terms of substitution. We'll always try to calculate delta W because this is the measurable quantity, this is the measurable work done by the system or on the system, and based on that we determine del U and del Q. So these two quantities are not calculated directly. So think about the constant pressure process. So in a constant pressure process, your work done, as you know, is given by P into V2 minus V1. Always keep the analogy of the cylinder in mind. Say in a system, the final volume is V2 and the initial volume is V1. So work done on the system, if done by a amount of work P, so it's V2 minus V1. If V2 minus V1 is greater than 0, that is the final volume, or let's say V2 minus V1 is less than 0, so this quantity becomes negative. So this, if you substitute here, it will be positive term because this is negative. So internal energy increases if work done on the system. What is meant by that? This is the piston. If the P pressure is exerted over there, suppose it is in equilibrium initially and P pressure is exerted over there, and this one is the initial volume V2, and after exertion of this pressure, the new position is this one is V2. So obviously the work is done on the system. So anything that any work that is done on the system is a positive work, and that increases the internal energy of the system. So from constant volume process, now let's derive what happens. So let's say del W in the differential form I will also write, that is P V2 minus V1, or in the differential form P dV V1 to V2. Okay. So from the first law, if we just substitute that, so I can write U2 minus U1, that is the final internal energy of the system. This is the initial internal energy of the system, is given by QP. Let's say Q2 minus Q1 is equal to QP. That is, QP amount of heat is being added or subtracted. I am not bothering about the sign now. QP, and the work done is as we calculated, V2 minus V1. Okay. So if we substitute that, if we find an expression for QP, which I have already said that cannot be measured directly,